again to this class. We'll be talking about Bayes' theorem. We'll be talking about frequency. We'll be talking about distribution, probability distributions, and all these things will lead us to probably binomial theorem if you have time or not. Then you can read up some of those things that are remaining. But today, I want us to try as much as possible to move faster, to be able to cover expected value and talk about some of those likely questions. How do they ask? What are we talking about when we're saying relative frequency distribution, cumulative frequency distribution, discrete? Out of discrete, we have what we call continuous also. But in your own case for now, is discrete we are talking about. So we'll look at discrete random variables. So from there, we'll be able to discuss some of the likely questions. How do they solve them? What are the things they will ask me? How would they? Don't just cram that one, but all you need to do is just to work hard. Work hard with what you have. But I will not lay more emphasis on the material because I know the material we're talking about here, some of them, I'll just do the summary. Like you always like summary, right? Now we have Bayes' theorem. I'll give us the formula for Bayes' theorem, and from there we move on. So the formula for Bayes' theorem is when we have, let's look at this definition first before I move to Bayes' theorem fully. Let's look at this. That the Bayes' theorem is stated as follows: given B1, B2, B3 to Bn, mutually exclusive events. Mutually exclusive events. Mutually exclusive events whose union is in the universe. Is the universe, and let A be arbitrary event in the universe, such that probability of A is not equals to 0. Such that probability of A not equals to 0. Then we have what we call P, probability of B, Ij or Bj given A. You still remember the definition for this. We discussed it here last week in our last class. So we are going to use this conditional probability this morning to be able to discover some of these problems. So we have probability of B, J given A. And the definition is probability of A given Bj divided by, divided by the sum. That is the summation of probability A given Bj. Divided by probability of Bj. Okay, sorry, let me put it this way first so that we can have better understanding. Let me still coming back to the same thing. Just hold on. Let me put it in this format so that we can have better understanding. Let's say we remember from the definition that the probability of AI given B is the same thing as probability of B given I multiplied by probability of AI divided by the summation of I equals to 1 to n probability of B given AI dot probability of, or let me just put multiplication by AI. What does that mean? It simply implies that anytime we have probability of A given B, the definition is quite this simple. We are going to have the probability of B given A multiplied by probability of A all over probability of B. If probability of B not equals to 0, because if probability of B equals to 0 at this point, meaning that you have undefined, you will have undefined. So we can now say that in this content, if I have probability of B given A, it's so simple, but it's a probability of A given probability of J, Bj, let's say J, multiplied by probability of B, Ej, divided by the summation of probability of A given probability of Bj, everything multiplied by probability of Bj. Now, what does that mean? It simply means if I want to write it in a broad language, it depends on the question. Probability of A given probability of J divided by, I will now be multiply them one after the other, meaning this one will have gone, this will have gone, so we remain this, and this is summation here, so we have it to be probability of A given B1 plus probability of A given B2 plus probability of A given Bn. Since our J start from 1 to n, so it depends on the value, a kind of value you were given. And don't forget our definition. One of the definitions we have here is that when you have this probability of A given probability of J, Bj, is the same thing as probability of A intersection. Who can tell us? We did it last week. Intersection what, please? Anybody?
Intersection B.
Intersection what?
B.
Say it.
B.
B, thank you. Intersection B. Remember B as a J. You put J there. Divided by probability of what? Anybody?
Probability of B.
Bj, thank you.
B.
So Now, in this case, that I know the definition of this or any of these, I can actually look for, assuming you are given this, if they give you this, and you are looking for this, you don't know this, what will you do? And you know this one. What will you do? How do you solve it? So what you need to do at this point is make the intersection a subject of formula. Just say A intersection B J is equals to, you cross multiply. This one will multiply this. It will now be probability of A given Bj multiplied by probability of Bj. That's all. So from there, we can look at the example in our book. It's there. And we will just look at it together before we move to today's work in proper. It's just a very short topic in our notes, and I will advise you please put, okay, let me just, so let's continue by saying, can you see the screen, please?
Yes, sir.
Okay, now let's look at this question. We have the question 1 says, let's write it down. 3 tutors are assigned to mark the assignments. I'll just shorten it, of hotel catering management, hotel and catering management students. In the university. So at the university, we have this. Then the tutor B1 marks 45% of the assignment. Tutor B2 marks 35%, while tutor B3 marks 20% of the assignments. Then the course coordinator vectored the marking and it is found that the first tutor has an error of 0.03. The second, 0.05. And the third, 0.04 error. So the question now is, if a script selected is found to have error, have an error, what is the probability that the script was marked by the first second, or third tutor, respectively. So let me stop sharing. Now, as we all know, that is an interesting question. I know some of us have been trying to solve it or check it, but because of the probably typographical error, you might not get the actual what they are saying in that question. Now, the first thing you need to identify is the population we are dealing with. Now, can you tell, and this question is applicable to our day-to-day activities. Where you are working, you can, probably you are a coordinator, or you are the director, or you, whatever position you find yourself, or you have subordinates under you that are working. You can easily use the principle, Bayes' theorem, to identify some of those things. It's very simple. The first thing is, how many scripts do we have the scripts? Or do you give assignment to people? Or is it a line of production? You have different line of production. Some of us that we are in a quality assurance, you know that the production line A, B, C, D, you have it in your factory. How do you discover error from, or you know that probably the error that's supposed to have here is 0.1, 0.2, 0.3. You identify those errors. How do you now solve the problem? So by the time you have the error, how do you identify who committed who? So let's go. Let's look at the probability now. And from then you'll be able to discover yourself. Okay. Now, the first thing is can somebody read the question from your side, please, so that we can solve it? I don't want to be going up and down, please. If your audio is clear enough, please read for us.
3 tutors are assigned to mark the assignments of hotel catering management students in now. The tutor B1 marks 45%.
Now,
of the
let's start
assignment.
from there. P1, probability of B1 is what? 45 divided by 100, which is equals to what? 0.45.
0.5, 45.
Okay, go ahead.
Okay. Tutor B2 marks 35%.
35 divided by 100, 0.35.
0.35.
While B3 marks 20% of the assignments.
0.3.
The cost
is it 30 or 20?
20%.
Okay, 20%.
Yes, sir.
Okay.
Should I continue?
Yes, please go.
The course coordinator vetted the marking and it is found that the first tutor has an error of 0.03%.
Don't forget, we are using Bayes' theorem because of, remember, we want to identify, we know the script. But how do we now identify who committed the error? The events in this case, they are B1, B2, B3. They are 3 of them. Am I communicating now?
Yes,
so
sir.
We need to now calculate, do the analysis in a simple manner that A given B1, when you fet it, A given B1 is what? Go ahead.
0.03.
0.03.
Yes, sir.
Go ahead.
The second is 0.05. And the third, 0.04 errors.
.04.
Yes, sir.
Okay.
Okay.
Right.
If a script is selected, if a script selected is found to have an error, what is the probability that the script was marked by the first, second, or third tutor, respectively?
Remember, A is representing the script now.
Yeah.
Given that each tutor marked them.
Yes, sir.
Now, the question now says, please read the question again. If
a script selected is found to have an error, okay, what is the probability that the script was marked by the first, second, or third tutor, respectively?
Now, the tutor will now be probability of, we want to see probability of BJ given a script. Will now be, we know that it is going to be probability of A intersection BJ divided by summation of probability of probability of A given BJ. So from that, we will be able to solve the problem. So from here, we can solve the problem. Let's now define what in your book, you see they draw a table in order to make it simple. We all know that summation means addition. Just add everything together. Now, we have events that says B1, which is tutor 1. Then what is the probability of B1?
0.45.
The number in marks, right?
Yeah.
Then probability of B2,
0.35.
then B3.
0.20.
Okay. Now, we need to calculate the probability of A given B1. A given B1, A given B2, A given B3. A given B1 is what?
0.03.
Is already in the question. So you've not done anything here. But we need the definition of probability of A intersection BJ. Don't forget BJ in this case, we can define it from here by saying probability of A given B1 is the same thing as probability of A intersection B1 divided by probability of B1. We know this, we know this. Can you see it now? Because it's already been given. So all we need to calculate is to calculate the intersection. Is going to be probability of A intersection B1 is the same thing as probability of A given B1 multiplied by probability of B1. So what is probability of A given B1, please? Is there in your notes?
0.3.
0.03.
0.03 multiplied by probability of B1.
0.545.
So what's the answer when you multiply it?
$0.0135.
0.0135.
0.0135.
Now, let's do the same thing to probability. Let's do the same thing for P of A intersection B2. Then P of A intersection B3. What is this? What is this? Just give me the final answer. Punch your calculator.
B2.
B2 is what?
0.0175.
175. Then the next. Is it the same?
0.008.
Please, how did we get our 0.03 B1? It's already given. Aduragbemi is there in the question. That is the probability. That's the error, the probability of error they committed. That's why I said it's already given. Any question? Okay, let's continue. So for the last column, all we need to do is probability of BJ given A. Remember, the probability of tutor, we pick probability of tutor 1 given the script. Remember, the course coordinator picked only one script, and that is why the one script is A. Assuming he picked more than one script is another question entirely. But at this time, he picked only one script, which represents A. And it will continue. We will now be pairing the script with the probability, with the script. We're pairing the script with the tutor. Now, okay, this script now, do we know whether it's tutor A, tutor 1, tutor 2, tutor 3, like that? Is that okay? So let's solve them. We already have it. I will just solve only one, then you complete the rest. Probability of B1 given A is equals to probability
I
of
don't know the page that you are reading from.
intersection B1. You said?
I didn't know the page number that you are. Sorry, I'm just
I'm not
coming.
giving you page number. I'm giving you the board.
Okay, sir.
It's probability of A given B1 plus probability of A given B2 plus probability of A given B3. Now, what you need to do is, let's add everything together here.
Sir,
Yes.
this B3 is 0.008. No, it's
What is the answer, please?
It's the same thing.
0.008. Is it the same thing?
It's not the same.
It's the same thing.
It's the same thing.
Okay, let me remove it.
Yes, sir.
Can somebody add this column together for me?
Yes, sir. Zero point zero 0.039.
39. Okay. So now what you need to do is, we have the summation here. For us to solve this one now, you go to the first, we are calculating the first one. So it's going to be probability of B1 given A equals to, what is the summation? What is the value for probability of B1 given A? The value is what? 0.01. 0.0135
35.
divided by what?
0.
Divided by
0.039.
Thank you. When you divide it, what do you have? Then you do the same thing to B2 given A. Then you do the same thing to B3 given A. What do you have?
The first one is 0.34.
0.34 what? To 4 decimal places, please.
Okay, 0.3451.
62.
62. Thank you.
60.
The second one,
0.4487.
0.039. 4487.
87.
okay. The third one,
0.2051.
2051.
Okay. Now you go and place it there. to each of the value here. So let's add everything together. What do you have?
Is
Is what?
1.00.
1.000, right?
Yes.
Your answer, remember last week when I was explaining to you, your answer cannot be more than 1. You are doing probability and your answer is 1, 2.3, 3.4. It simply means you are missing something somewhere. Any question?
Yes, I have a question. I got confused how you got probability of B1 given A, and then probability of B2 given
Probability of B1 given A. Remember that you already have what a probability of B1 given A already.
Yes, sir.
Probability of how do I put it? You already have probability. Oh, I think that was.
Sir, please show your screen.
So please show your screen from the formula part, please, before the question.
Okay. See it.
Under it, not here. Okay, thank you, thank you.
But sorry, there's something you put out. Okay.
Sir, please take it down small, please.
No, not
Okay,
you
sir.
alone. Others are also writing. If you cannot meet up with the writing, you can watch the video. We can't wait for you. You can punch your calculator and do it.
Well, I missed the formula. That's what I want to do. I did not jump anything.
Are you okay now?
Thank you.
Okay, thank you. Okay, you asked the question here. You said probability of B1 given A.
Yes,
You already have B1 here, given A here. We already have them here. Remember from this, when we remember you are given this, we have this before, and we use this one to get what we call, we use it to get this.
Yes, sir.
So we put it inside the formula, and probability of A given B1, just to find A intersection B1, because it was not given. Now we have A intersection B1, A intersection B2, and A intersection B3. Now, substituting it here is so straightforward. Remember that the one denominator here, they call them summation. And we stop at 3 because we only have 3 tutor. Tutor 1 plus tutor 2 plus tutor 3. And we already have the definition here that leads to them from here. So that is how we got there. I believe I've explained. Okay, let's proceed, please. Now, there is something we call Another interesting area is the relative frequency distribution. Relative frequency distribution. Yes, Gift.
Yes, sir. Please, sir, I don't know. How do we know that this is what you're supposed to use for this probability? How do you know that you're supposed to apply Bayes' law for it?
Bayes' theorem.
Yes, Bayes' theory, not other probability.
Remember, I mentioned something initially that, let's look at this. Look at this definition first. When we're saying mutually exclusive events whose union are universal. For example, the Bayes' theorem has already been stated. Remember, the other probability, they will only, if it's conditional probability, they will only give you only one. It is only, they will only give you only one, like, for example, like the one we did last week, talking about A given B. But in this case now, not only one person that are involved. If the question says, did a tutor mark this and the lecturer, the course coordinator vet, and he discovered that that will make a mistake, what's the probability that the script they pick is for that tutor? How many tutors that mark it?
Only one tutor.
Only one tutor. So there is no need for you to pass through the Bayes' theorem. Are you getting it now? But in this case now, we have 3 tutors and we only pick only one script. And the question did not tell us that they label their parts. They just pick it probably at random. And we are able to establish that the number of errors committed, the probability that, okay, the one I pick is for A. We already show it. Look at it now. The probability that the first tutor is the one that committed that offense is this. Okay, which of them is the highest? The chances is high.
B2.
B2.
Is what?
B2.
B2. And I can tell you, by the time you scrutiny the B2 tutor, that, okay, tell us you are the one that marked this thing, you will discover that the answer is between B1 and B2.
B1 and B2.
Because the last tutor only marked few, remember, and the error is also, the probability of committing the error is also high a bit. You can see he only marked few, 20%. But B2 marked 35% of that total script. We don't know the number of thousands of the script. They didn't mention it. So you cannot discover from here that, okay, the error, the script will belong, is either it belongs to A, B1 or B2. But most likely, B2 is the owner of that script. I hope I've explained it now. Any other question? Okay, let's continue. Yeah, in this case, we'll be talking about, some of us that like to play Lotto, we'll still be talking about it. And please don't play it in exam. Just remember you make the payment. Or do we have, how many of us are on scholarship? How many of us are on scholarship here?
Sir, does now offer scholarship?
No, you say you. You don't speak to others, for others. Edith John, are you on scholarship? Okay. You will see now, I will call somebody that the person will tell me she's on, he or she is on scholarship. Nkeji Angela, are you on scholarship? Nkeji is nowhere to be found. You can see people on scholarship will not answer me because they know they are on scholarship. Okay, then Betitilayo, are you on scholarship?
No, sir.
Aha, you can see now. Those people that doesn't, they will answer you sharp. Okay. Aminu, Ahmad, are you on scholarship? You don't need to hide your face. I can see you already. Are you on scholarship? Oh, okay. You will see some people are on scholarship. I'm sure of that.
No, sir.
No, okay. Ahmed Sanusi, are you on scholarship?
Sorry, sir, what do you want to do to get scholarship from now?
You said?
What do we do to get scholarship from now?
No, sir.
No. Okay. So if you are now on scholarship, please don't play it local. Okay? You have to be sincere. Now, okay, let's continue. Now that we are now on scholarship, now the probability at this point, we have it to be given as the probability, I will just be shortening it, of an event. You recall that we discussed this one last week, says S equals to xi is given as the probability of Si to be X. That's a probability, and that 0 less or equals to probability of S equals to Si less or equals to 1. Remember, any given probability will be within the interval will be 0 to 1. It cannot be negative and cannot more than 1. So take note of that. So that's the first probability that I told us last week. And it's still the same thing as probability of an event, probability of E less or equals to 1. So event can be S1, S2, S3 to Sn. That is the event. The event can be, they are both mutually exclusive and collectively exhaustive. Meaning, anytime you have inclusive, mutually exclusive, we're talking about summation of probability of X equals to Xi, which is equals to 1. Let's take notes. Now, the question is, suppose a die is not there to, normal die we normally use when you are playing Ludo, is what we are talking about. When is, we call it dice, when it's more than 1. So if it is 1, it's just a die. Is thrown 20 times. 20 times. And the frequent distribution of a throw is shown below. Now let's look at this. We have a lot of questions. We're going to this question, this number 2 question. I'll be referring to this number 2 question till we finish this topic. So we have xi to be, and we have the frequency. We have 1, 2, 3, 4, 5, 6. So, and we have number 1 appear 2 times, 2 times, 4, number 3 4 times, number 4 6 times, number 5 4 times, number 6 2 times. So can someone tell us why do we stop at 6? Can you tell us why do we stop at 6?
But we only have 6 numbers.
A die. We only have 6. Die has only 6.
Yes, a die has
A
6.
die is what? How many?
1 to 6.
6.
1 to 6.
Yes.
Now, if it is a card, how many?
Card is small too.
Card is what?
2 sides. 2 sides.
Oh, 52. You are on your own. Some of you that you don't play Ludo, that you think Ludo will take. Somebody say 54.
24.
Okay. Let's type the number. Type the number of the card, the total number for the card.
24.
Type it on the chart. We will see the people that play. We will see the people that doesn't play.
Please still tell us the actual number.
Is what?
So we don't know. Can you tell us the actual number? We really want to know.
You want to know? You never play card for you?
So please, what type of card, Biko?
Okay, what type of? Tell us the one you know.
I know.
So card is 52.
Card is 52. Okay. Oh, somebody has already Googled it. Imagine. So you will see. Okay, some people say 20. Esther, Egba, which of the card are you talking about? Do you think it's greeting card or which one?
Card is 52.
Card is 52. Adeoye Felicia. What is the number of cards, total cards, you know?
52.
Unmute yourself, man. Is how many?
52, sir.
52.
Yes, sir.
Okay. Somebody say 54, 54, 52. Now, all these things are very relevant. Some of us, we don't take care of it. Examiner will just tell you from a card. Remember, they just mentioned, nobody give us the number of die, but we know that a die contains 6 faces. They will not tell you. They know it's a common thing. A card is 52. Go and check it. What type of card is 52? Wisdom. Unmute yourself and talk.
Playing what? What? Normal
what card? Somebody say what card? Is it what card? Okay.
Is what card?
Okay, no problem. Let's continue. Now, we're talking about die now. Die is 6 faces. That is why you see.
I'm aware that.
That is why you see that we put, yes, Chris Cash, what's the question? Okay. Like I said, the question now says, find the distribution of this discrete random variable. The probability is 1. Now, how do we find the distribution? For example, how do you know so the probability, look at the question, says so we need to find probability of, if I ask you to find probability of x1 equals to 1, it simply means the frequency 1 divided by total frequency. What is the total frequency, please?
20.
20.
20. Thank you.
Yeah.
So what is the first frequency? Well, now, the S1 in this case is what?
2.
2 divided by 20 is what?
20.
10.
0.
Oh.
0 point.
Hey, mathematician, 10. 0 point what?
1.
0 point.
Okay. Now let's find the probability of, let's get for the x2. What's the frequency of S2? S equals to 2.
0.12.
That is, we are taking it one by one. X1, S2, S3, S4, S5, S6. Is what?
0.1. 0.1.
Is 2 divided by 20, right?
Yes.
0.1. So what is the for the S3, probability of S3?
0.2.
20 is
what?
0.2.
4 divided by 20
20.
is 0.2.
Yes.
This aspect is very important. So what's the probability for the X4?
0.3.
0.3.
0.3.
And S5?
0.2.
0.2.
S6?
0.1.
Let's sum everything together. What do you have?
1.
1.00.
1.0. Have you seen it now?
1.
That the
Yes.
summation of the probability, like I told you here, for an event is equals to 1. So now that is not where we are going. We now have some question under it. As a matter of fact, they can give you a table like this and ask you to calculate. I'll give you the question now.
Yeah.
Now you need the grill. You remember. Don't say, hey, enjoy the moment while it lasts. Yeah. It is well. Roman figure 1 question says, what is the probability that a throw will give value of 3? Roman figure 2. What is the probability of getting in a throw four or five. Then number 3, look at it. They can give you table and ask 3 questions. Imagine what is the probability that the value of the throw will be more than 3.
Okay.
So who can tell us the first question?
What is the probability that a true will give value of 3?
So what is it? How do we calculate it?
3 divided by 20.
Eh? You don't need any division anymore. You already have, you finish with division. Division is to get their probability. How does it work? How do we solve it? Somebody's, okay, you are still talking about card. Okay, what is the probability? Anybody?
Divided by 20.
What are you dividing by 20 again?
You
already divided it by 20.
4 divided by 20. 1.
And then what is the probability? I only asked for the answer.
The answer is 0.2.
The answer is
0.2.
0.2, sir. 0.2.
2.
The answer is what?
0.2.
0.2.
0.2.
0.2.
Okay. How many of us don't know how we got the 0.2?
I don't know.
I don't know.
I don't
Lion,
know.
what did you say?
I don't know.
I don't know how they
You
got
don't
the
know.
I don't know, sir.
Yes, sir.
Okay, let's look at it together.
S1 is 3.
Look at it. They said the value of 3. We know the first value,
0.2.
the probability that if I throw the die, I will have 1 is this one.
Okay.
The answer is this. This is their probability. Although when I throw it, by the time we are trying to play the Ludo, when I throw the die, throw that a die, I have to, it appears 2 times in my own case. But the probability that when I throw the second die, when I throw the same die, I have 2 is this one. The probability that when I throw the third, I will have the 3 will appear. This is the probability. Remember, this is the value. The one that I circled here, they are the value of the die we have. Are you getting it?
Yes, sir.
So the probability that when I throw that die, 1 will appear is 0.1. The probability that 2 will appear, forget about the frequency that's in the middle.
Okay.
But let's talk about the probability that when I throw it, 1 will appear. The frequency will help us to be able to know the probability. Why? Because it's the total number of time it appears. But the question is, what is the probability that when I throw that die, 3 will appear? Is 0.2. Yes, gift.
But if it's thrown once, I think it should not be 3/6.
Assuming that we don't have frequency, let's say every if it is only die that you did not appear, we are not talking about frequency now. It's just going to be 1/6, 2/6, 3/6, 4/6, and 6/6. Is that okay?
Okay. Yes.
I hope it's clear now.
Yes, sir.
Yes, sir. Very clear.
So it simply means that at that point, when I throw a die, let's say we don't have frequency, they are not telling us the number of times. Just throw 1, it's just going to be 1/6. But since we are given the frequency, the table, so we have to work with that. So the first answer will be 0.2.
2.
Because that's the probability of S3, right?
Yes.
So now the second question says what? Anybody?
Probability of getting in a true 4 or 5.
Is what?
0.5.
Just like that?
No, we plus.
Guys,
Plus
0.3. 0.3 plus
0.3
0.2.
plus 0.2.
3.
That's 0.5 now.
0.3 plus 0.2 is 0.5. 0.5.
Which one should we pick?
0.5. 0.5.
The question says what?
What is the probability of getting in a true 4 or 5?
4 or 5.
4 or 5. It simply means probability of 4
plus
5.
Probability of X equals to 4, right?
Yes, sir.
Or 5, which is same thing as probability of X equals to 4 plus probability of X equals to 5. Remember last week when we were talking about OR, I said it's addition, right?
Yeah. Yes.
So, which means, what is the probability of 0.4 from your table?
0.2.
0.3.
Probability of 4.
0.3.
It's
0.2.
Madam.
Well,
S is for
0.3.
not frequency. We are not talking about frequency now. Don't mix it together.
0.3.
This is what we are saying. Are you getting it now? Just do like this in your notes.
It's killing. Okay.
So it's going to be
0.3.
0.3 plus what?
Yes,
0.2.
0.2.
That's all. Now, the third question says what? The third question, please.
What is the probability that the value of the true will be more than 3?
Will be more than 3.
Yes, sir.
Okay. So is what?
Probability of 4, probability of 5,
0.6.
0.6, sir.
probability of 4, 5, and 6, and add it together.
The question says, what is the probability that the value of the throw will be more than 3?
More than 3.
It simply means probability of S
4
greater or equals to what?
1.
Hey. Interesting.
0.3.
More than 3.
4, 5.
Is 0.3 plus 0.4. Sorry.
4, 5, 6.
So what's the answer, please? Remember that at this point, what you need to do, everybody please listen. What you need to do at this point is check which of them are we talking about. Number 1, more than 3 means it cannot equal to 3. Are you getting it now? It will be more than. Then if it's something is more than 3, if you say S greater than 3, where do we start from? But when it's a greater or equals to 4, you mean that it's more than 3. You are starting from 4, 5, 6. Add all the value together, and that's all. It's so simple. Probability is one of the simplest topic so far, because your answer will not more than 1. You know that one for sure. Then let me look at it. Just to interpret is the question. Thank you, Professor. Somebody put it there, 0.6. Is it 0.6?
Yes, sir. 0.3.
0.6.
Thank you. Okay, if you now said, let me add another question.
Okay.
What is the probability that the value is less than 4?
It's less than 4.
0.4.
0.4.
Addition of 3. 0.4.
0.4.
Addition of 3 to 1.
1, 2, 3.
Addition of what?
1, 2, 3.
1, 2. Addition of 1, 2.
Addition of
1
1,
0.4.
0.4.
0.4.
0/4.
0.4, sir.
How do you do it? Explain.
Addition of probability.
0.1 plus 0.1 plus 0.2.
And plus 0 points.
Plus 0.2.
Okay.
Which is that 0.4.
Oh, okay. I believe we have it now.
Yes.
Any question, please? Okay, I will give us this question, and I want everybody to solve it. Now, A less than 3.
Please, I have a question.
Go ahead.
Under the frequency table, after the calculation of the x summation, the x, the probability of x1, the total number is 1.00. I didn't get how
You didn't hear what?
I didn't get how they got the 1.00.
Just add everything together from A to Z. That's all.
Something else.
Is this you are getting something else?
Yes, sir.
Please check your notes.
Okay, sir.
Thank you. Okay, everybody in 1 minute, can we solve this one?
Please, sir, please scroll down to the table.
You don't copy the table at all? See this woman, no?
Number.
Okay.
Thank you.
Here is the table. Or
for less than 3 is 0.2.
Yes, Victor. Just do your own. And Arasiola, do it in your notes. Victor, what's the question? Odelola Victor, you raise up your hand.
Thank you, sir.
So less than 3, more than 3, at least 3. At least 2.
So I'm done. Can I say the answers?
No. So what's the first answer for the first one?
0.2.
0.2.
0.2.
0.2.
Somebody say no.
0.2.
0.2. 0.2.
The first one is what?
0.2.
0.2.
Yes.
Yes.
Okay, the second one?
0.6.
0.6.
The last one.
0.6.
The last one, 0.1.
Wait, the second one you said what?
0.6.
0.6.
0. No.
How did you calculate 0.6?
So you did it.
So you said more than
0.2.
more than 3.
Okay. So at least 2.
0.1.
0.1.
At least 2 is okay.
0.1.
Now when we say let me write this one. It simply means more than 3 means probability of X. That's less than 3, right?
Okay.
Right?
Yes, sir.
So the next thing is, when it's less than 3, it simply means that we have 2 ways of solving it. Probability of S equals to 1 plus probability of S equals to 2, or 1 minus probability of S greater than 3. You can use it. So then B, we have probability of more than 2 or more than 3 is probability of S greater than 3, which is implies probability of S equals to 4, probability of S equals to 5, plus probability of S equals to 6. Then the C aspect is probability of S greater or equals to 2, at least 2. That is 2 inclusive. That's meaning. So you start from 2 to the end. Any question? I believe we are tired.
No.
No, sir. We are with you, sir.
Yes.
Okay, let's do it this way. I want you to stretch yourself in the next 5 to 10 minutes. Then we continue. We want to do the last phase, talking about discrete random variable. Those ones also common. It's just have a 5 minutes break, just 5 minutes.
Sir,
Don't
please,
go out.
excuse.
Don't leave that place.
Sir. Sir.
I'm not talking to you.
Please, I want to ask you something.
You are in break.
Hi.
You want to ask question in break?
Hello, sir.
Yes, so any question for me? I'm here.
Sir, I mean I just joined the meeting, sir.
Okay.
So
What can
I want you to explain the topic of today for me.
You said what? I should explain the topic of today.
Yes, sir.
For you, we have a lot of lecturers in the house.
Hello, sir.
Yes, ma'am.
Unregistered lecturer. Good morning, sir. Sir,
They are. No, you don't need to. Yes, good morning, ma'am.
This last question, C, at least 2. Some people are bringing 0.9, some are bringing 0.8, and some are bringing 0.2. So, sir, which one is the right answer, sir?
And which one did you get?
If it's at least, I think it should be either 0.1 or 0.2. I mean between the 0.1 or 0.2.
Read the question again. Okay, wait. Let me just give you this scenario. In your association, you have to contribute the money. They now said, okay, favor, at least give us. Okay, in this society or in this class, you must, let's say, for example, you have to buy a particular thing, probably in the family. And I said, okay, at least you must contribute at least 500,000. At least. Or 50,000 naira, at least. It simply means he can do what? He can more than. Are you getting it now? Unmute yourself.
Can be more than, yes, sir.
That is what we did. For example, we know that they said at least you cannot below that 50,000 naira. You agree with me? The minimum is 50,000 naira. You must contribute. So the maximum cannot be continued. That okay, maximum is 100,000, 500,000, 300,000. It depends. But you have to start from that minimum amount. At least 2. Probability of 2. Meaning it can be probability of plus probability. How many do we have? We have 6 faces. So they now say at least 2, meaning that what happened to the rest had everything together.
Thank you, sir.
You're welcome, ma. Answer now, what's the question? I know you look confused. We are hearing you now. Go ahead. Why are you confused?
Sir, I'm not confused.
Okay. No problem. Please don't be confused. Okay. The judges so far, I believe it's clear. We can proceed from here.
Yes, sir.
Agbaka, can you hear me now? Probably your network.
Yes, sir.
Okay, thank you. So let's move on before we call it a day or before we call it a semester. So we have, let's do the cumulative relation frequency distribution. So under this particular cumulative frequency distribution, we have what we can construct a discrete random variable there. So I don't need to give us the notes. There are notes in your book. You can, it said cumulative frequency distribution is important in computing the probabilities of some events. We will need to construct the cumulative relative frequency of the discrete random variables in case you have them. For discrete random variables, we have the, let's say we have discrete random variable X. Then the cumulative relative frequency of Si is given as the probability of S less or equals to Si for Si equals to 0, 1, 2, to N. Hence, we can have, if I say probability of S less or equals to 4, what does it mean? Simply means probability of S equals to 0 plus probability of S equals to 1 plus probability of X equals to 2 plus probability of X equals to 3 plus probability of S equals to 4. So we have this. Then we can also say, remember our table. Our table says Si, Fi, we have 1 to be 2, 2 to be 2, 3 to be 4. I'm still referring to our table. 4 to be 6. Then our 5 to be 4. Our 6 to be 2. Then we have the probability of S equals to SI. Then the cumulative relative frequency to be probability of X less or equals to SI. So we have it to be 0.1, 0.1. We have it so this one will be, now we all know the cumulative frequency, the way we normally do it. 0.1 plus 0.1, you add the next 0.1 to each other, 0.2, 0.2 to 0.2, 0.4, 0.4 plus 0.3.
0.7. 0.9.
Yeah.
1.
So from there, we can now solve the problem. If I now ask you, what's the probability? How do we solve this one? Somebody should solve it now. The probability of S less or equals to 4. What's the answer? Then also, what is the probability of getting a value between 2 and 5 inclusive? Inclusive, remember this word, inclusive. How do we solve this problem? Inclusive. What's the first one, please? This is the first question. Second question is here. What was the first one?
0.7.
0.7.
The first one,
0.7.
Correct. Then the second one is what?
Second one will be between 2 and 5. 2, 0.7.
0.7, sir.
0.4.
The second one.
0.8. 0.8, sir.
Is 0.4.
8.
Put it in the chat, please. Let me see.
0.1.
Just put it in the chat. We will see it together.
.2 alpha 0.2. .8. 0.8.
The answer is what?
0.8.
Oh, okay.
When in the sample.
Some say, oh, okay, let me see. 0.8. Joseph, Diana, 0. You are wrong. It cannot be 1.1. I just told you several times that probability answer cannot more than 1. So where do you see 1.1?
No, him.
0.8, sir.
Okay, let's look at it together.
The first way they close. See that waiting we do. Either he come out without telling the guy. Also, you know.
Okay, let's look at it together. The question says, what is the probability of getting a value between 2 and 5? Inclusive. That's why I underline inclusive. Simply means probability of S less or equals to 5 minus probability of S less or equals to 1. Which means from our cumulative frequency, I can use the cumulative frequency and deduct it. What is probability of S less or equals to 5 in cumulative frequency?
0.9.
Is 0.9 minus
0.1.
What is S equals to 1?
0.1.
Which is 0.8. I know some of us did not do it this way. Or in your own way now. Let me follow your own way. Probability of S equals to 2 plus probability of S equals to 3, probability of S equals to 4, plus probability of S equals to 5. Remember, inclusive. Some of us will be like, no, why did you start with, it's supposed to be, is it not between 2 and 5? It's supposed to be probability of S less or equals to 5 minus probability of less or equals to 2. No. So this is the correct way. The two option that I gave you is the correct way. 0.1 plus 0.2 plus 0.3 plus 0.2, 0.8. Any question? Fail for 0.5, where did you see it? Okay, Joseph, Solomon, Omega, okay. Irene, where do you see 0.22? Please, let's watch it. So let's take note of that. Last but not the least, still on the same table, I will use the same table for the expected value. If you've seen the expected value question before, it's there in your notes. So for the expected value, how do they do it? We have measures of probability distribution. Here we have the mean expected value. They call it the mean of the probability. You can ask this question. is what? Is the expected value of the random variable that has the specific or that specify distribution. That specify distribution. Question can be find the expected value of x. Which is expected value of x. It's represented like this. You can now say the definition will be e of x equals to summation of si, probability of x equals to si. We know this. We know this one, and we know this one from our table. I'll still give us the same table now. Si fi 1, 2, 2, 2, 3, 4, 4, 6, 5, 4, 6, 2. So then we have probability of x equals to xi. We know it. 0.1, 0.2, or 0.1 rather. 0.2, 0.3, 0.2, and 0.1. We all know that the total is 1.0, right? Now we need to calculate this SI, expected value, for P of x equals to xi. So how do we calculate it? They can give us the table, like I said, and ask us to calculate it. For expected value of x is E of x. It's the same thing as, that is, you pick one, look at the formula. The formula says xi multiplied by probability answer that we get, meaning that our SI, let me just do the arrow again, this multiplied by this, that is the meaning. And put them in the front. So in the calculation, in a simple calculation, it's going to be 1 multiplied by 0.1 plus 2 multiplied by 0.1 plus 3 multiplied by 0.2 plus 4 multiplied by 0.3 plus 5 multiplied by 0.2 plus 6 multiplied by 0.1. So at the end of the day, what's the answer of each of them? This one will give us 0.1. Am I right?
Yes, sir.
0.2,
0.4.
0.4. Okay, you're on your own.
0.6.
Thank you. If you copy the one in your book, you will score 0. Better listen. Press your calculator by yourself. 4 multiplied by 0.3.
0.12.
4 multiplied by 0.3.
1.2.
Thank you. 5 multiplied by that.
1.0.
6 multiplied by 0.1.
0.6.
So add everything together. What do you have?
$3.7.
Thank you. 3.7. Now, question is, but this man told us that probability should not be more than 1. Remember, this is expected value. We are not talking about probability now.
Okay.
We are using it. We are using probability value to get expected value. So it's more or less that what we have done is we are doing the mean. We call it mean.
Okay.
Which is same thing as mu, or which is same thing as expected of x. The formula is the summation of SI, probability of S equals to SI. Remember, from our descriptive statistics, our mu is the same thing as summation of F of I, SI, divided by summation of F. How do I know that I'm right? You can do that by saying, go to your table. F, if I want to do that, I can do it this way by saying this multiplied by this. 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 And this multiplied by this. So when you multiply them, it will give you an addition of it will give you this. That is what I'm saying is one multiplied by 2 plus 2 multiplied by, it's not part of it. I'm just trying to show you something that we have done me. That's what we've done. 3 multiplied by 4. Everything divided by 20, because the total frequency is 20, right? Or what is the total frequency, please?
20.
So our meal will be 74 divided by 20, which is 3.7. So it's still the same thing. They can ask us to calculate variance from here. The formula for variance is so simple. It's expected value of SI minus mu all squared. But I will not give you with all these jargons. I will just give you this. Let me just give you the formula straight by saying E of S squared minus E of X all squared. That's the formula. This is the formula for it.
So I'm not seeing your screen.
Is your network. Others are seeing it.
I want to see your picture.
Oh, that means you like me.
Please, I need this screen.
That is why you are seeing my picture alone. Who is not seeing it?
So can you share your screen back so that we're not done writing?
Yeah, I know. Because somebody said you are not seeing it. Can you see the screen now?
Okay, yeah, I
Yes,
can see it
very
now.
well.
So, in your table, you can also create on your own. How do I get to this point? I will just give you this method to do. Go and do it by yourself. This is the column you need on your table. You already have some, so which you don't need to do the problem. So if you can do this one, you can use this formula to solve it. Meaning at the end of the day, you have to add everything here together, this particular place. Then you can do this one also together. Don't forget that you already know, you have this one already. You know the answer. The answer for this one is up. Is here, 3.7. Just say 3.7 squared. That is what you need for here. That's what you need from here. This is 3.7. This is 3.7 squared. So this one is the one you get from here. Then you get your final answer. Please, can you do it by yourself without any? Don't ask anybody. Solve it by yourself. Let me stop sharing. I believe is the class interesting, please? Or am I just talking to myself?
Very, very sir.
Is it interesting? Did you gain
Very
anything?
interesting.
Yes.
Yes, we learned a lot.
Capital yes.
Okay. Madam Titilayo, did you gain anything?
Yes, sir. A lot, sir.
A lot. Okay. Some people have not talked in this class from day one.